Hello, I'm Kevin, VK6 Lima Whiskey, Victor Kilo 6 Tango in contests. And it's just a little bit of a follow-up on yesterday's video where I posted some information about a double-size extended double ZEP antenna, or DEDZ antenna. And this was modelled for the 10 metre band, and I had it at a height of around about 6 metres height. And a very good gain figure. Gain figure was around about 13.5 dBi. But at that height, the main lobe, if you refer to the previous video, was at around about 24 degrees above the horizon. So it wasn't a particularly low angle of radiation. So I've just been playing around a little bit more with the modelling here, adjusting the height of the antenna. And if you go from 6 metres to 7 metres or 8 metres, all that really happens is that you get a much larger main high angle lobe in the middle here, which is not really all that desirable. The gain stays more or less around about the same, around about 13.5 dBi, but you get this high angle component. So I pushed it on a little bit further and I thought, well, let's just see if we go to 11 or 12 meters in height, let's just see what happens to this antenna. I mean, essentially what happens is the higher you go, the more the ground reflection comes into play. So at 11 meters height, it's obviously just a bit over a wavelength in height. But that's not, 11 meters is not unachievable. And it's quite interesting. The main lobes with the gain, they are then lowered from the 24 degrees from the 6 meter height version down to 14 degrees. And you're still getting 13.62 dBi, so there's no drop off in the gain at all. Plus you've got these secondary lobes. I think this one here is 46 degrees, it's still 12.86. And if we have a look at the minus 3 dB point here, we've got something around about, sort of probably showing 8 degrees and going over to 6 degrees there. So you've got something probably around about 7 degrees at around about 11 dBi. Which is still pretty impressive. So the pattern looks exactly the same really. We've still got this very narrow beam width, but we have a lower angle of radiation, which has got to be better for long haul DX. So this is the same antenna modelled at 11 meters height, the DEDZ, and once again I think if you can't manage to get a beam up, this is a very good option. I've also modelled this on 15 meters and I've modelled this on 20 meters as well, and it scales well for each band. You can see the SWR here is still very low. It's under 2 to 1 over 500 kilohertz, which is pretty good. Obviously if you want to optimize it for the CW end of the band, you can make this antenna a little bit longer. A sort of cheating way of doing it is just to make the stub at the center a little bit longer, and it will bring the SWR down lower in the band there for CW. If you're interested in the phone end of the band, you can optimize it up this end. It's pretty straightforward stuff. The other interesting thing with this antenna is you can change the position of the load. Change the position of the source, I should say. So the source at the moment is in the center. If we have a look and we change the position of the source to one end, so now I've moved the source to here, you can see that we've got it looks like, you know, this may be a problem. You know, we've got the source at one end, we've got these collinear open wire stubs here. So if we run the fast forward plot, we'll see that essentially it looks pretty well the same. In fact, it does. Still got 14 degrees, 13.72 dBi, actually a slight increase on before. We have a look at the 3 dB point here. It's more or less the same. It's 8 dBs, 11.88. Yeah, it's probably peaking out around about 7 there. So you could, if it's convenient or more convenient, you could actually run the feed point from this open wire stub. This one is closed, this one is closed. You still get exactly the same pattern, but what happens is it becomes slightly asymmetrical. So if we have a look at the azimuth slice here, you can see that on one side there's more side lobes here, which are not really affecting the overall pattern. It's not having a massive effect on where you really want the signal to be going. but it might be useful from a practical point of view if you're not able to easily access the center of the antenna, or the supporting the weight is easier at one end than the other, that type of situation. Okay, 73s for now from me, Kevin, VK6 Lima Whiskey.